Let's do this thing. Slope fields. This is short and sweet. I know you like and love, you can do these, but they're handy just to know a few deals. A slope field is like giving you the feel for the, if you have a differential equation, the slope field gives you like the shadow of the actual function. It's like anti-deriving. It shows you a picture of the antiderivative on there. The shape of it is giving you a sense of what the antiderivatives look like. So when somebody came up with this, they just, all you're drawing is little tiny tangent lines, little specks of a tangent line, and you put them together and you get a sense of the shape of the original function. It's really cool. So think back to ancient times, pre-Leibniz and Newton, who had developed our system of calculus. That was how they figured out if you had a rate of change differential equation, these slope fields were a good way to say, oh, that's what the function was. Ah, yeah, I can see it in there. And so it's like a, kind of like a magic orb that tells you your original function. So here is the idea of a vector field is kind of like a slope field. If you guys like vector fields, then you can look at that. But then, if we turn the page, we want to talk notation for a minute. Here is a differential equation. Sometimes we write it like dy dx and then we put a little xy. Like that means at a given xy, here's the slope. Or you can do f prime of xy. That's good to know. Slope of a tangent. It is the slope of a tangent line to y, or the function f, at a given x input point. Okay, down below. So here, shall we draw a little bit of a slope field? Should we try it? Should we practice? It's been a while, hasn't it? I'll get out my pink. You get out whatever color you want. And I think we should race. Don't you think? Okay, on your marks. So I'll do the first one with you. If you go to the point 2, 1, that means x is 2. I put it into my differential equation and I get out 4, a slope of 4. So you draw a little tiny slant with a slope of 4. If I go to 1, 1, my slope is, when I put 1 into the differential equation, I get 1 squared. Notice y has no bearing whatsoever on the slope, and that's okay. Sometimes y is not an effect on it. And your marks, get set, I'm going to freeze, go. It's all about winning. Oh, stop it. It's okay if you win, just not before me. Man. I don't know how to be a loser. I'm trying to figure this. My whole life, my parents said. Okay, I think we got this. Bingo. Oh, yeah. Isn't that cool?
No.
A lot of people beat me. I'll get over it. Okay, so anyway, there it is. Hey, if we think about this, just wait a second. The derivative is x squared. What was y? X cubed-ish. And does that does the shape of this look kind of like an x cubed ghost? Are you seeing it? Ooh, yeah, you're seeing the trend inside there. So that's a family of x cubeds going on in there. You can see the shape of it. So it's like the ghost of x cubed. That's the deal with slope fields. It gives you a hint at what's underneath there. Very important. Pretty cool. Okay, I'm going to back up. So let's try a specific solution. So what if I said, give me the differential equation, or solve the differential equation when you go through the point 0, 0. Okay, let's say 0, 0 is an initial condition on that function. You would actually go to 0, 0 and then follow the trend of this. You just surf the slope field waves from that point. You catch their trajectory. You just hop on the wave, the slope field wave, and then you get that nice curve. That would be through 0, 0. What if they said the initial condition was 0, 2? Then you catch the wave at 0, 2. It's awesome, man. You ride it. So that gives you that nice sense. It's definitely like a shadow or a shape, the general shape of that original function. Okay, that's what we do with slope fields. Let's move to the next página. Look at that. Here's our curve again. Same one. A little more detailed. Same differential equation. Check it out. Look at all those. Isn't that pretty? Can you see it some more? Can you see the... Look at those cubics. It's nice. Just a family of cubic curves. Each one of these is basically some kind of oh no, I'm gonna write this one. Like ax cubed plus c. Each one of these just has a different plus c. That's what's happening. All right, on our way down. This one here, what if I give you this differential equation? What's interesting is it's a non-separable differential equation. We don't have a technique to solve for this, not the ones we've been using. You can't get y on the left multiplicatively and x on the right, and you can't integrate because we're going to have this plus issue. So slope fields are kind of our only out. So there comes a time when the techniques of finding the exact solution aren't working for us. So if I go to the slope field now, and if I go in here right now and fill in these with my nice pink lines, let's go to 0, 0, I'd get 0. Just double check my work. When I go to 0, 1, I get 1. When I go to this one, I get 1. When I go here, I get 2. When I go to 2, 1, I get 3. When I go to 1, 1, I get 2. And so on. When I go to 0, negative 1, I get negative 1. Negative 2. Negative 2, negative 3. Yep, I like this one. Negative 2, negative 1 is negative 3. Negative 1, negative 1, negative 2. Now we're getting kind of approximate. And I think I got this. Okay, so you get these nice little slope lines as you draw them in there. Again, that's approximate, and today I'll show you, I loaded the program that you can put in your calculator for slope fields on your calculator. You can use it anytime there's a calculator question, and it'll draw these nicely for you, so you don't have to come up with it yourself all the time. But if I go to 0, 1, check this out. 0, 1, that's the points right here. You just ride that wave. You try and catch on to what's going on in there. And I misdrew these, didn't I? I think, did I miss one? I think I'm good. Which one? Negative 1. Oh, yeah. Negative 1, positive 1 would be canceled to make it 0. Gracias. Went fast. And 1, negative 1 would be 0. Because it canceled. Gracias. There we go. That helps a lot. Now when I put that next one in there, you ready? If I catch it at 0, negative 1, catches that wave and takes off that way. So you can catch the wave, catch your slopes, and have a blast. And we'll hit the road. And this gets steeper as you go up. And if I had the rest, you'd have it on there. Now, we're going to keep going because I'm looking at the clock. We have 30 minutes to get to some meat and potatoes on this. There are lots of problems that are just practice. Some of them are multiple choice, match it with the slope field. Some is finish those out. They are pretty short and sweet, but they're the variations on the type of slope field questions you could get on the exam and with me. A couple of AP exam problems. So Monday and Tuesday we'll finish those off. I just wanted to give you a hint. Okay. We're not going to do any more with that. We're going to go purple. We're going to switch. So slope fields. That's enough of an intro on that one.